Good evening, everyone. This is MD Suhail Ahmed from Electronics and Communication Department, H section. Project on topic Smart Lighting System Visualizer using pulse width modulation. I just want you to give a brief clarification about my project. So, the conventional lighting systems operate at fixed intensity, leading to unnecessary energy consumption and limited adaptability to environmental conditions. So this project proposes a bio-inspired smart lighting framework inspired by the Dragonfly vision, capable of dynamically adjusting the illumination based on ambient light, occupancy detection, and the emergency events. The system utilizes the pulse width modulation for efficient brightness control, and a MATLAB based simulation and scenario modeling framework with the 3D visualization is developed to analyze different conditions such as low ambient, medium ambient, high ambient, rockfall emergency, and the gas leakage scenario. The simulation results demonstrate that the proposed system reduces the emergency consumption under normal conditions while ensuring the 100% illumination during the emergencies or for the enhanced safety. So, main file we have specified all things, and here I am calling the paths like I have specified the paths here for the test cases. As you can see here, functions and the test cases have been saved here. So here these lines will call those paths, and the energy results will store the results and the test names. Here this part will give you a menu drop down for the selection, and this switch choice, this switch case will let us choose a test case to be seen. Next, this part will select the worker occupancy, and this is the run logic. So let us run our main file. Here, as I have stated, here we get a drop down menu for the selection. Let us say a low light. There is a low light. It means we have a low ambient light, that is the natural light present. So there is a very low natural light present, and let us take the worker present. So, and this is a 3D visualization of our project, and let us first see the graphs, then let us come to this 3D visualization. And here you can see three plots about the low ambient, which is one is about the brightness and ambient, other is about the occupancy and emergency timeline, and the another one is about the energy consumption, fixed the traditional light versus the our Dragonfly smart lighting. So here, as you can see, this orange light specifies the ambient. As there is a very low ambient, the brightness of our smart lighting system is high. So this will ensure that our lighting system behaves based upon the environmental conditions. So here there is an here we can see the worker occupancy, like this blue line states the worker occupancy, like this flat line tells us there is a worker present, and this area will tell us that for this time period there is no worker or the person present. So our energy consumption will vary based upon these two scenarios, based upon the ambient light and based upon the worker occupancy. So let us see the 3D visualization. Here you can visualize here these white circles, or we can say the spheres, are meant to be the lights. So let us change our condition to low ambient, it means there is a very low. This green dot means there is a worker present, and here you can see the calculation parts. The mode is active mode, and we have built it for a better visualization. So like this our project is there. And here in our test cases we have specified all the test cases. The gas leakage, it's an emergency test case. I will show you an emergency test case. The gas leakage and the rockfall is an emergency test case, and the normal test cases are the low ambient, medium ambient, high ambient, and the no occupancy present. So these are the things. And next there is another file, as we have specified here, the function file. Here in the function file we have all these codes, that is dashboard UI. As we have seen the dashboard, the display result, this display result will be shown in this command window. Here all the calculation parts are being done, as we have seen in the dashboard also. This is a mode of operation, active mode, and the brightness level, PWM cycle, how much PWM cycle is has been done, and the smart lighting energy used versus the traditional energy used, the energy saved and in percentage we have calculated. So this part is done with this display result. Next, energy calculation. The energy calculation has been done. The lightning logic will let us to decide based upon our selected condition, and the plot advanced graphs will be plotted. So let me just show you an emergency condition, and let us see a rockfall emergency when the worker is present. So let us close this dashboard, and here you can see the same three plots. And here, based upon the emergency, the lightning is changing irrespective of the ambient light. The ambient light may be anything, like there may be high ambient or low ambient, it doesn't matter. Whenever there is an emergency, the our smart light system will give a brighter output. So the energy consumption will be vary based upon these scenarios. As we can see here, there is an emergency condition for this time period. The same for the same time period there will be the change in the energy consumption. So like this our smart lighting system will work smartly. So coming to this comparison graph, here I have given you all the comparison graphs from where we can easily know the energy consumption of different scenarios. For the low ambient, here you can see the blue lines, and for the medium ambient, this moderate energy usage, the orange one, and the red one, and high ambient, as you can see here the yellow one. There is a very, as we know, when there is a very bright natural light, so we don't want an artificial light to be brighter. So likewise this energy consumption will be reduced. And the two conditions, rockfall and gas leak emergency, for these two conditions, based upon the time period of the what we can say, the time period of our emergency condition, the energy consumption will be vary. So this is our project. Hope you like it. Thank you.